Welcome to lesson 9.4. We are looking at multiplying binomials and still today. And recall yesterday we talked about the FOIL method, which has us multiplying our first, outer, inner, and last terms. If we look at our first row of activities here, we've got a binomial times a binomial again. But notice how both of these binomials are the same. The same here and here. Go ahead and take a moment and FOIL those and see what happens. Go ahead and restart when you've done those three problems. If you look at the result, what ends up happening with our outers and inners is we're getting the same value. And so notice how our middle term is basically the outer times 2 or the inner times 2. Notice how we have a square here and a perfect square here. The same thing is happening with y plus 5 times y plus 5. Again, notice that if we take our outers or our inners and double it, that's what we get. And the same again here. Notice in this case we've got a perfect square and another perfect square. If we look at the next row, we now have the difference. Okay, we now have that difference of d minus 3 and then d minus 3 again. So when we FOIL, we are left with d squared minus 60 plus 9 and t squared minus 2t plus 1 and 81r squared minus 36r plus 4. So again, we've got perfect squares here and here. And if you look at just your first and your last term in either polynomial or either binomial and multiply them together and then double it, that's what your middle term is. Now, in this case, notice how we have the opposites. Now think about what your first term is going to be. Think about what your last term is going to be. But then, most importantly, think about your outers and inners. In all three of these situations, your outers and inners are going to be exact opposites of one another. So what ends up happening is your middle term in your trinomials, what would have been our middle term here, is now canceled out. Okay? These are what we call special cases. Let's look at example 2. Or excuse me, example 3. So we've got p plus 6 times p plus 6. Can you do that without writing your outers and inners? Can you see that your outers and inners will combine? Here, the same thing. Here, your outers and inners will make each other disappear. Now that you've seen some binomials in action, let's think about what's happening. Okay, this is a common mistake students make, is that they will see the quantity a plus b quantity squared, and they will say a squared plus b squared. They will just distribute that square to both of them. The problem is they're forgetting about those outers and inners that are happening with both of these. Remember, anytime you square a binomial, you will still get a trinomial. Okay? Don't forget about that. And that is both the same with if we are adding our a and our b inside the binomial or subtracting it. Notice how our middle term here is dependent upon that the sign separating the two terms. When we've got the product of the sum and the difference of the same two terms, okay, what's going to end up happening is we get that a squared minus the b squared. That's not happening up here, okay, when we're squaring two binomials. So you have to really think about that. Go ahead and try the A and B examples here. I'm going to do those. With example A, we've got y plus 11 squared. Think about what's happening. If I write it this way, students will tend to give me y squared plus 121. When they forget to think about that as y plus 11 times y plus 11. So we can take, and again, we FOIL, and we end up getting y squared plus 11y, and 11y is 22y plus 121. And again, this is a very common mistake that happens is they forget about that middle term. In the next example here, we've got 3w minus 6 quantity squared. So again, that's 3w minus 6 times 3w minus 6. Got to watch our signs here. Our first terms are going to give us 9w squared. Our outers are going to give us negative 18w, and then our inners are going to give us negative 18w for a total of negative 36w. And then our last term is going to be 6 squared, which is plus 36. Go ahead and try a few of the quick checks here and check your answers when you're ready. Here we can see we end up getting t squared plus 12t plus 36. In B, we get 25y squared plus 10y plus 1. In C, we're down here, we get 49m squared minus 28mp plus 4p squared. And then in D, we've got 81c squared minus 144c plus 64. All right, I've jumped ahead a little bit to example 3, and here we've got 81 squared. The nice thing about knowing these special cases are that we can break down our problem, 81 squared. Think about what 81 is. 81 is 80 plus 1, right? Times 80 plus 1. So knowing what happens and recognizing the pattern with this, okay, we can square 80, and what do we get? 80 times 80 is going to be 6,400, right? That's our first term. Our outers are going to give us 1 times 80, as well as our inners, which give us 1 times 80, which gives us 80 plus 80, which is 160. And then our last terms is going to be 1 times 1, which is 1. So the beauty of knowing these special cases allows us to do some mental math without a calculator. Okay? Notice I didn't pick up a calculator at all. And I can quickly then add, and I get 6,561 as 81 squared. And again, you can check that on your calculator. But you don't need to necessarily use just square 81 times itself if you can break it down this way and follow the pattern. It will be much more helpful for you if you are trying to do some mental math and you don't have a calculator. Now let's think about what 59 is. Okay, 59 is 60 minus 1, correct? So again, knowing my pattern here, I can take 60 and square it, and I get 3,600. My outers and inners are both going to be negative 60, which combined makes negative 120. And then my last term is going to be 1 plus 1. So I can take 3,600, subtract 120, which leaves me with 3,480, and add 1, 3,481. Go ahead and try a couple of these in your head or quick scratch them down on paper and see if you can get them, and then check them with your calculator. Now let's look at example 4 here. In example 4, notice how we have, these two terms are the same, and the last two terms are the same, and our signs are opposite. So think about the fact that our outers and inners are going to cancel out again. So we have our first terms, which is going to be p to the 4th squared. What does that become? That becomes p to the 8th. Think about your rules. Our outers would be 8p to the 4th, and our inners would be minus 8p to the 4th. So those would cancel out, and then we're left with our last term, which is 8 squared, so it's minus 64. Okay? This is the difference of two squares here. So this is a square, these are the same, or this is the difference of a square. Notice how these terms, the binomials, are both opposite of one another. All right, hopefully you have done the quick check 4, and go ahead and check your answers. And then we're going to move on to example 5. Example 5 has us multiplying 43 times 37, okay? And think about the process that we've been working with foiling. We can use that to our benefit, and we can take 43 and make it, again, we can make that 40 plus 3. And then 37, we can take and make that 40 minus 3. Do you see a pattern? Remember, because we have the same binomials, just with a different sign separating our terms, we can square the first one, and we get 1,600. Our outers and inners are going to cancel out, and then we can subtract 3 squared, which is 9. So 43 times 37 is, without a calculator, 1,591. See how quick that was? Go ahead and try the quick checks, and when you're done, check them with your calculator. Here I've recorded the answers for you as well. So we've got 396 for 5A, 5B is 399, 5C is 3,050, and 5D is 8,091. Please make sure you bring questions to class tomorrow, and we will continue multiplying binomials by binomials and binomials by trinomials.